In this lecture, we're going to deal with the single most important topic in finance and wealth management. That is the time value of money. Every day we deal with issues related to money and time. How much should we save for retirement? How much should we save to put kids through college? Or if you're more like me, how much should I be saving to buy a yacht in 10 years' time so that I can sail around the world? Or how much do these football stars really get paid? If we consider a more mature example, in 8 years' time your child will be attending college. You estimate that to cover the cost of college you're going to need $95,000 in 8 years' time. Currently your bank is offering an interest rate with an APR of 5.5% compounded monthly on a long-term savings account. How much money would you need to invest today into your long-term savings account to ensure that you have $95,000 in 8 years' time? We have to deal with time and money here. Another example, a less mature example I grant you, would be a $5 million football contract. A University of Iowa graduate tells you that today he has signed a $5 million 3-year contract with a pro football team. And the basic contract structure is the following. You get a $1 million signing on fee, and then you get $500,000 per year for 3 years. And payment is at the end of each year, starting 1 year from today. In addition, he's also getting $125,000 per year for 20 years, starting at the end of the 4th year from the date of signing. The total amount the football player receives is $5 million. But how much is this contract really worth? Is it actually worth $5 million today? The current interest rate is 5.64% compounded annually, and it's expected to remain constant over time. Both of these problems, saving for your kid to go to college or working out the value of a football contract, are dealing with the concept of time value of money. Essentially, people prefer to receive a payment of a fixed amount of money today rather than an equal amount in the future. Why would you rather have $100 today as opposed to having the $100 in 10 years' time? Well, there's opportunity cost. Money today can be used today, or it could be invested. And if you invested it, then over time you would earn interest. And if you recall from compounding, we could earn interest on the interest. So $10 today is worth a lot more than $10 in the future. Now let's think about some key phrases for time value of money. Discounting is the opposite of compounding. Consider the example we had in the previous lecture on interest rates. We had a $100 investment and we earned 6% per year compounded annually, and we invested for 5 years. At the end of those 5 years we found that the $100 we invested today would be worth $133.82 in 5 years' time. Now suppose we see that we have $133.82 in 5 years' time and we want to know how much it's worth today. What we have to do is remove all that compound interest, and if we did that using the process of discounting, we would find that $133.82 in 5 years' time is worth $100 today. When we discount money, we need to know the interest rate we're going to discount the money at. Similarly, when we're going to pay compound interest, we need to know what the interest rate is. Typically in finance, the interest rate will either be called the interest rate or the discount rate. They're the same thing. It's the rate of interest used to discount one or more future cash flows. Present value reflects the current value of one or more cash flows occurring in the future, while future value is the amount to which an investment will grow after earning compound interest over a period of time. We'll use all these phrases throughout the rest of this lecture. Now, there is a formula to calculate the present value of future cash flows. The present value of a future cash flow, FV, is going to be equal to the future value divided by 1 plus the interest rate to the power of capital T. FV is the future value after capital T time periods. Capital T is the number of time periods, and R is the discount rate per time period. Essentially, this formula is saying that money in the future is worth less today. If T increases, then the present value is going to decrease. If R increases, if the discount rate increases, PV will decrease. And if FV increases, then PV will also increase. That's what we can see from the formula. But to be honest, I don't like formulas. I prefer intuition. And the way I think about time value of money is actually visually. If I hold a $1 bill right up in front of my eyes, the dollar bill appears to be very large. As I move the dollar bill away from my eyes, I see the dollar bill get smaller and smaller. That's actually the way I think about the time value of money. Money today is like the dollar in front of my eyes. It's big. As I move that money into the future, so the value of that money to me as I see it today gets smaller. So I always think about these problems visually. But we do have this formula, which we will use throughout the class. With this one formula, you can solve any problem as regards wealth management and financial management. Let's consider saving for college. First of all, let's convert our problem into the language of finance or wealth management. How much money do you need to invest today in order to have $95,000 in 8 years' time? We know that the APR on our savings account is 5.5%, and that's compounded monthly. What's the discount rate in this problem? Well, the discount rate is going to be a monthly discount rate, because compounding is monthly. How do we calculate the discount rate? It's going to be equal to the APR, which is 5.5, divided by 12, which equals 0.4583% per month. What is T? What is capital T? We have 8 years. T is going to be 8, but we're doing monthly compounding, so it's going to be 8 years times by 12, which is equal to 96 months. What is the future value? The future value in this problem is $95,000. We want to have $95,000 in 8 years' time. What is the present value? That's what we need to calculate. That's how much we would need to invest or save today in order to make sure our kid could go to college. Let's use the present value formula to solve this problem. First of all, I like to draw everything on a timeline. And we know that we want to save some money today in order to have $95,000 in 8 years' time. And the 8 years is equal to 96 months. We know that the discount rate, or the interest rate, is equal to 0.4583% per month. And what we want to do is bring this $95,000 back to the present day. We do that with our formula PV equals future value divided by 1 plus R to the power T. All we have to do is plug in the numbers. We know the future value is 95,000. We know the discount rate is 0.4583% per month, so that's 0.004583, all to the power 96, which equals 61,246.95. If we want to ensure that our child can go to college and have enough money, we would have to invest $61,246.95 today. And in 8 years' time, that would grow to $95,000. Or equivalently, visually, $95,000 8 years into the future is the same size as $61,246.95 today. That pile of money, $95,000 piled up in 8 years' time, looks the same as a pile of money that is worth $61,000 today. We're going to extend this saving for college example in the next lecture, but for now that was the first example of present value and future value. Let's increase the complexity slightly now and deal with our football contract. Recall that the basic structure of the contract was that the player received $1 million today. They then receive $500,000 per year for 3 years, with the payment at the end of each year. And then after that they received a further $125,000 per year for the next 20 years. The interest rate is 5.64% paid annually. What is the discount rate? The discount rate in this example is 5.64 because the compounding is at an annual frequency. What's the future value? In this case, we've got multiple future values. We have $500,000 paid for 3 years at the end of each year, and we also have the $125,000 paid per year for 20 years. The future value is a stream of cash flows. What's the present value? Well, the present value is what we need to calculate to see if this contract is really worth $5 million today. Let's put it onto a timeline. We receive $1 million today as the football player, and then for the next 3 years we receive $500,000 each year, and then from year 4 onwards we receive payments of $125,000. Now we could use our formula, present value equals future value divided by 1 plus R to the power T. And we could do this for every single payment. We could do it for the $500,000 here, and here, and here, and so on. We could calculate the present value of each payment and add them up, and that would be the present value of the football contract. But that's going to take a long time. In reality, there are some tricks we can use to speed things up. One of those tricks is how to value an annuity. First thing to think about is, what is an annuity? An annuity is a stream of level, equally spaced cash payments between 2 points in time. And the formula for the present value is as follows. The present value at time small t is equal to the cash flow at time t plus 1 divided by the discount rate, and all of that is multiplied by 1 minus 1 divided by 1 plus r, the discount rate, to the power of t. That is the formula for an annuity. C is the amount of the constant periodic payment. T, capital T, is the number of time periods. And R is the discount rate per period. If we look at a timeline, our formula for present value is calculating the present value of a stream of payments with the same dollar amount in each payment made over a series of months or years. Now let's return to our $5 million football contract. Can we use the annuity formula to value this football contract today? You might like to say yes, because we can see we've got payments every year for 23 years. The problem is that to use the annuity formula, the cash flows have to be constant, or the payments have to be constant across all the years. We have $500,000 for the first 3 years, and then we have $125,000 for the rest of the time. So we can't use the annuity formula because the cash flows are not constant in all time periods. What do we do then? What we're going to do is split this contract out into 3 components. The first component is going to be how much do we receive today. That's component 1. Component 2 is going to be the $500,000 payments that we receive in years 1, 2 and 3. That's the second component. The third component is the $125,000 payments received for the remaining 20 years. We're going to value each of these components separately and then add them up. How do we value components 1 and 2? Well, component 1 is $1 million received today. What is the present value of $1 million today? Well, it's $1 million. That bit was easy. What's the present value of $500,000 received in years 1, 2 and 3? We can use our formula again for present value. Present value is equal to the future value divided by 1 plus r, all to the power t. In this case, we've got 3 cash flows, so we're going to have to do 3 calculations. The present value is going to be equal to 500,000 in 1 year's time, which will be equal to 1.05. The present value of 500,000 in 1 year's time, which we calculate by dividing 500,000 by 1.0564 to the power 1, plus the payment from year 2, that's 500,000, and to discount it back to the present day, we're going to use 1.0564 to the power 2, and then we receive the same payment in the 3rd year, 500,000. We will divide that by 1.0564 to the power 3. If we do that calculation, I get 1,345,458.05. We've now valued components 1 and 2. What about component 3? This is difficult. This is where you need to be very careful and draw timelines. What is the present value of $125,000 received in years 4, 5 up to year 23? Our first payment starts in 4 years' time. We know that the payment is constant. C equals $125,000. We might be able to use the annuity formula. And the annuity formula says that the present value at time small t is equal to the cash flow, the periodic cash flow that starts at time t plus 1, divided by r, all multiplied by 1 minus 1 divided by 1 plus r to the power capital T. Our first cash flow is at time 4. If we're going to use this formula, we would have to be calculating the present value at time 3 is equal to the cash flow at time 4 divided by r multiplied by 1 minus 1 divided by 1 plus r to the power t. In other words, we are going to calculate the present value as if we are standing at time 3. Let's plug in the numbers for the present value at time 3. We're going to get C is $125,000 divided by R, which is 0.0564, all multiplied by 1 minus 1 divided by 1.0564 to the power t. There are 20 periods, so it's to the power of 20. And if we do that calculation, we get $1,476,599.39. That's the present value of this stream of cash flows, but it's the present value in year 3. In other words, this stream of cash flows will be worth $1,476,599 in 3 years' time. That's not the present value today. To calculate the present value today, we have to bring that 1.4 million back to the present day from year 3. We have to bring this cash flow that we've now valued at year 3, has to come all the way back to today. How do we do that? We can use our present value formula again. Present value equals future value divided by 1 plus r to the power t. We will get the present value today is equal to 1,476,599.39 divided by 1.0564 to the power 3, because we need to bring that cash back 3 years, and that is equal to 1,252,499.34. We have now calculated the present value of component 3. So what's the present value of the football contract? The present value of the football contract is just the sum of the 3 components. Component 1 was worth $1 million today. Component 2 was worth $1,345,458.06. And the third component was worth $1,252,499.34, which equals $3,500,000 $197,957.39. The contract, when it was announced to the media and to the public, was that it was a $5 million contract. In fact, that contract is worth substantially less. In fact, it's worth almost $1.5 million less than the club advertised. The contract is worth just over $3.5 million. The contract is worth just under $3.6 million. Still a lot of money, but it's nowhere near the $5 million that it was advertised at. Hopefully these two values have illustrated the key concepts with a time value of money. In the next lecture we're going to deal with a more complicated example. But for now you just need the intuition that money, a set amount of money today, is worth more than that same amount of money in the future. See you in class.